Good afternoon to everybody, respected chair and eminent speakers and the august body. I am really thankful. In a very short notice, I have been invited to give this lecture. Actually, our director, Dr. B. Venkateswarlu, was to come here because our DG is visiting flood-affected areas during this period. Dr. ILSI-INDIA. That's why I went there to accompany him in place of him, and I was deputed to present this thing. So, since yesterday we have been talking about the water, then different GCM models, downscaling approaches, and then all these things have been talked, but in reality, actually, if you look at the rain-fed agriculture, the variability which is happening in the real time is very, very important to cope with. And of course, first we have to standardize the data sets for modeling purpose through effective experimentation and throughout the India and hotspots where we have the systems to be implemented. Then only we should come out long-term effects on these things. Some of the things which we have done as a part of this NICRA project, I think probably you all know, National Initiative on Climate Resilient Agriculture, the CRIDA is the host institute, and we are implementing across the India, involving different agriculture universities and our ICR itself, and some private institutions also. So, some of the work which we had done in the Andhra Pradesh, and I would be talking about actually what work we have done in Andhra Pradesh with respect to the climate change adaptation and then mitigation systems. And regarding mitigation also under the well system, as Dr. Vasan told, we have worked out actually CO2 footprint for different different crops with the different water management systems which we have in the market. And I know if you look at these basic statistics of Andhra Pradesh, the wells, almost 29 lakh wells are available and indiscriminately put across the fields in the search of water. That is where actually people are failing to get actually water because the variability in the rainfall, seasonal rainfalls are going down, and even the rainfall amounts are decreasing. So that's why coming to the rain-fed area which we have in Andhra Pradesh, almost 15 districts have about 55 lakh hectares is out of the rain-fed area which we have in Andhra Pradesh, particularly in Telangana. Most of the Telangana is the rain-fed except a few spots in the Nalgonda and the Karimnagar, which comes under canal irrigation under the Nagarjuna Sagar. And the remaining parts of this Rayalaseema region, of course now, this Andhra is getting divided into two states. I think this may be the last lecture about the United Andhra. You may see again two states coming up. They are going to split this. And then things would change because of administration. So, what are the problems in the rain-fed, particularly in the areas in Andhra Pradesh you see here? The most of the area is affected by the land gradation, soil erosion, because it is mostly untreated, and particularly in the farmers area, there is a good program launched by the government of India, integrated watershed development programs and all. In spite of that intensive program put in place, still there is a lot of land degradation happening within the farms. Actually, on-farm soil erosion is too high because there is no treatments, coming to the farmers across those fields, and even farmers are not ready to accept that. That is where actually the real climate resilience, if you want to really put the adaptive capacity to the farmers at the field level, on-farm level, now these soil and water conservation methodologies has to go into the field. Then only, soil and water conservation problem is, whenever you want to put these NRM interventions at the farm level, individual farmers are actually afraid of, you're not ready to accept the, first of all, technologies to put in the field, because they have to change their way of practicing their farming practices. Even plowing across the slope is not being practiced. Even putting even contour bunds, graded bunds. Of course, we have lot of research information technologies are already available, well evaluated over the different agriculture ecoregions, but still they are yet to go to the field unless we make really a reform in the structural thinking, and also the the agriculture technology improvement. It's very difficult to achieve, particularly in the rainfeds. Rainfeds is the most affected because of this climate change. Now coming to the adaptation, water management issues which I am going to talk about in the rainfed. First thing is rainwater harvesting, which we tried in the Andhra Pradesh. We designed actually the farm pond. Farm pond as a climate resilient unit for the on-farm water harvesting and also the resource conservation, particularly water and then nutrients and also the soil at the local level. How to use them, how much is actually likely to coming into, how we can recirculate entire resource, being lost from the farm into again his own land, and what are the systems again, how to use that water to a farmer with the efficient irrigation systems and so on we tried. And we have put all this technology in the 7 districts of Andhra Pradesh in convergence with the state government. About 1350 farm ponds have been dug out, our designs have gone into the farmers' fields. Now, as you all know, there is a lot of potential for the rainwater harvesting, both in the red and black soil regions. So the model for the rainwater harvesting, we need to have some catchment, a farmer's field, and then the runoff potential of that particular area, and the runoff, and then storage structure to store that runoff. We know in the watershed program, most of the works are being done in the way of putting check dams and some gully structures, gully prevention structures, and all these things, which are all actually not related to the particular farmer owned by, they never owned by the community. And somewhere in the public lands, they make a check dam, water is stored, and they never use it. But ultimately, because of these structures, definitely there is an increase in the groundwater. Groundwater improvement is realized in all places wherever we have the watershed program. But the way it is being used by the farmers, and it is very, very less. But if at all a farmer wants to own water within his field, now naturally we have to go for soil and water conservation and also the structures like farm ponds. These are some of the in situ soil moisture conservation which are already developed in our Akibra centers. You can see here the conservation furrow made across the flow can improve around 25% increase in the production itself, apart from saving the soil and water. Because soil moisture is the major driving force which improves the crop production. Then in the cotton, this is again P in the ridge furrow system. And this is the one actually in the about 14.5 hectares area, taking 14.5 hectares area, we developed a mini watershed program in our own research farm, and we estimated different potential of that area. Then if you look at this data, there's a lot of variation in the intensity levels actually, rainfall events, which you can see there. Because the runoff coefficients, even though this information is lacking actually everywhere, the intensities and the duration, now the whole entire happening of this rainfall pattern in terms of, it's just like a pulse input coming onto the land surface at very short time, very high intensities, and then entire, whether if crop is there, crop is also damaged, along with that your soil is also lost for the field. So if we have such structures, we have the opportunity to put, arrest all these kind of things, and again reutilize that water whenever you have the dry spells. That means the localized risk can be easily reduced if you have these systems in the place. This is in the 2010. So rainwater productivity. The productivity can be improved again by having different irrigation systems. This is the data over the 3 years which we used to develop for the groundnut as well as this okra vegetable crop, which was earlier, it never happened in that form. This is again for maize and groundnut in the 2011 where the seasonal rainfall was far below the normal rainfall. About only 50% of the amount seasonal rainfall was received. But because of these success, we could actually put some of the area under irrigation and brought that. And you can see the production level almost 50% increase in the rain-fed areas. So this is the where a farmer has to go in now, because this is the 2012 scenario. 2012 we had a rainfall in the summer months, very burst of about 50 mm rainfall in the April itself. All farm ponds were full, and in the summer cultivating and the rain-fed the pulses and all, it is very, very difficult. And it's it's not a normal case. But we could cultivate pulses during the summer, then Kharif, supplemental irrigation, and Rabi also, because when the cessation of the Kharif season, we had again rainfall, and almost all farm ponds were full. We had again have the opportunity to irrigate bring some of the crops in the Rabi also. That is how, this is the all things which actually contribute to the adaptive capacity, because unless the income levels, if you don't improve income levels of a farmer, and he is nowhere actually. The capacity comes there. This is the example, and we had used this rain gun irrigation system with the 3 HP diesel pump set, which can cover more area with the less labor requirement as compared to sprinkler and all. Sprinkler actually, the hand move systems require at least replacement of the system very frequently if you want to cover 1 acre. But here in the rain gun, it covers more area within 1 hour or 2 hours. We can easily complete that because it covers more area. And again, this outflow of farm pond is also connected to recharge shafts within the farm. We have not allowed any water to go out of that, out of the research farm. That is how the model climate resilient agriculture can be very well seen on actually that research farm, Gunegal research farm, which was we have under the CRIDA. And this is again one way of doing the drip irrigation in the Sapota. These are all grown as rain-fed crops in the rain-fed that in Telangana region. But the yield levels are very low. So we have introduced the micro jets and this drip irrigation system. And we have really improved almost 70% increase in the yield levels as compared to rain-fed, and a lot of water saving. This is another micro catchment levels with the half moon water harvesting systems here in the mango. This is the actually initial year which we have now. Almost that crop is grown very well. Actually earlier this field was a wasteland actually. There was no crop at all. But we have made it a mango garden now with the water harvesting system. So that is how. Now if you look at this graph, that's what I was telling. If you look at these climate DCM models downscale data, which we downloaded from the CCAPS website. CCAPS means that Center Climate Change and Food Security from the ICADA. They have Maxim DSAT software, where we can have, we can download that entire data for, like all climate data. Rainfall, daily rainfall, temperature, maximum, minimum, relative humidity, solar radiation, and wind velocity, and so on. So we tried for two, well-cited models, ECAM5 and CSIRO, which are mostly used in the, even cited by the IPCC for doing this analysis. So if you look at, decadal changes, from the base data about 1980 to 2010, and it's almost reducing. I mean, rainfall has reduced, but all these models predicted there is a shift in the rainfall from June to July, where actually our natural monsoon starts from June 15th. But these models predicted at least 1 month off. That means starting from actually July. June almost only sparse rainfall, but from the July onwards, but extended towards the end of the season, October and November. So these kind of shifts are available. Then as part of this thing, I mean, to do this climate change analysis by taking, I mean, long-term this thing, as earlier our people were telling, we need a data set by Dr. Jayaraman and then Dr. Washman, as all were talking about the, the field data, the genetic coefficients for each location. I mean, it is, and for even different crop varieties, they are very much necessary if you want to accuracy in the crop modeling. Right? So of course there are default values which we are available for different sets in the DSAT model like that. But in the aqua crop only we have some few crops put in there. But compared to your region, and the climate is variable, and even your systems are variable, your management practices are different as compared to other regions. So to simulate all these things, we need to have a systemized data through experimentation. First to go for validation, and then we can go for, putting long-term effects on this thing. So that exercise we are doing. Yes. And we use this aqua crop model. Of course, the first, second year, 2 years data is over. And second year, of course, we are validating. With the first year data, we have simulated the, for the maize crop under different supplemental irrigation strategies, and also crop management like mulching and then increase in the fertilizer. In the rain-fed ecosystems, a farmer actually in worry when to apply fertilizer itself because rainfall dependence. Occurrence of rainfall is very uncertain, and he has to wait for the rainfall even if you want to put the resource into the farming system. So this is the thing happening. So, but when water is available, he had the chance to put at the right time to apply all resources available. I have seen in Andhra Pradesh, even people are carrying water by their own bullock carts, even purchasing water, water tanks are being sent to the fields by purchasing water. This is the level of, in Prakasam district, people are purchasing water tanks for spraying purpose because they don't have water. So this menace has to be reduced unless we make a localized success. On-farm water management is the crux of the problem. So these are the things which we did through aqua crop, and of course model predicted well. And the previous data which you see, these are all the simulated calibrated values for different physiological parameters, and also the coefficients. And here water productivity, model efficiency is more than 0.9. And all of course, this year data we have also collected through experimentation, we'll be validating it. And I think next we'll go for the climate change analysis. And these are the crop water production functions for maize under different irrigation strategies, under mulching and all. You see that there is a lot of gap between when you have increase in the fertilizer as well the water. If both put together with the mulching, there is a really jump in the water production, this productivity. So that is where actually, this is the experimental details. And now another exercise we did for knowing all these water management issues with respect to CO2 emissions. We worked out the CO2 footprinting for different irrigation systems, considering drip, sprinkler, rain gun, and this rain gun, sprinkler, and then drip under the well irrigation system. So these are the trends. Of course, tube wells are increasing in the Andhra Pradesh at 9%, and then these dug wells are almost coming down, with minus 1.7% down actually, as when you see the data over from 1993 to 2010. And these are the pump distribution in the Andhra Pradesh. So that's why on average we have taken 5 HP pump capacity to estimate the CO2 emissions. And once if you want to establish one borewell infrastructure, he has to spend at most 4 types of energy. He has to dig the well, then some casing pipes have to go in material manufacturing, and then pump he has to install. For manufacturing that pump also he requires some energy, right? Then for pumping, again for operationalizing this thing, he requires energy, that is the connection, power requirement. And all these things we have worked out for different this thing, except one component left out is, after using water, what are the emission rates for India? That data is not available in the Indian soils and all. Of course, for the rice, as Dr. Washman mentioned, there is a Philippine soil, but in the rainfed actually where you have these borewells and all, our soils are very poor in quality and the organic matter content, right? So the potentials of carbon emissions and all will be definitely low in our soils, and these have to be measured across the Indian soils. And once that data comes, I think it will be done. And then, of course, our people are still working out all those measurement, this thing, at different places. So this is the, if you look at these graphs, see, pump itself takes care, a lot of energy, through which actually this CO2 emission is very high as compared to other components, right? Under all irrigation systems, so surface, rain gun, sprinkler, and drip, all these 4 systems were compared. And this is the for CO2 emissions for sugarcane, and actually drip is the one which actually gives the lowest rate of CO2 emission. That is the best alternative available. And this is again percentage reduction. Actually in the drip irrigation, there is a maximum reduction in the global warming potential in terms of CO2. Then the maize and cotton, the crop water balance also we have seen by taking data from the CCAM5 and CSIRO. Almost for 9 districts we have done this exercise. If you look at in the graph, first graph, for the this cotton, in almost Andhra Pradesh, this Telangana region, 60% of the area of the traditional crops which earlier used to be under sorghum and this castor were replaced by this maize and cotton. Even rice is replaced by the cotton because of this reduced groundwater levels. So coming to that, looking at all these changes in the crop crop land use, then we worked out this thing. There are always deficits in the different decadal deficits in the there are decadal deficits for the cotton. But when you see the ECAM5 and all at a different ECAM5 A1B scenario for the Warangal districts, the almost deficits have decreased. Now it is a surplus. So that is the thing, because there is a shift. Actually, these all crop water balance is only for growing period of the crop. Cotton is grown over the almost 7 to 8 months. This is another Adilabad. Adilabad is the maximum rainfall receiving area, about 1,000 to 1,200 mm annual rainfall. That also we had seen. But here, if you see in Adilabad, the deficits are more with the normal sowing under the ECAM5, but again the deficits have enormously reduced, almost 80% reduction in these deficits. So like that. Yeah.
You're 26 minutes already, so.
Yes, what I mean to say is, we need to actually now improve if you want to actually put all these adaptive capacity of the farmers, particularly in relation to water management. Like carbon credits, we must introduce water credits like that. Some incentive should go to the farmer, because even to put this kind of small structures like farm ponds in the farmer's field, it is very difficult convincing a farmer, which actually it has multiple use and a lot of income can be brought to the farmer who is sustainable production. So like carbon credits, let us have some water credits as an incentive to the farmers so that the things can be improved. And really, I mean, that is only the way. If you have water, you have agriculture.
Irrigation.
And that is the simple thing, right? Thank you very much.